So hey guys, it's me again, Deshaun, and now you've taken all the photos you need to now be able to analyze your data for whatever trial you're on at this point. And I'll be helping you go through this process right now. So what you want to do first is you want to go to your browser. I am on Mac, so I'm going to use my Safari. And so you want to search up ImageJ. Alright, so it's just image and a J. And then you should get to a downloader that says download right here. Where I have my mouse on. Alright, you just click on that. And yeah, that will go through the whole entire process of downloading it. And once you get it on your desktop or wherever, you can start doing your actual photos. So you should probably have your your folder that you made during their photo taking in like your desktop. And once you have that so I have a sample photo right here, and I'm just gonna drag it into the ImageJ icon in the bottom. And yeah, it should pop up. Give a second. Okay, and here it is. Here's a sample photo I took of my worms. So now you have your photo in ImageJ. So you're in the program, you go to Analyze, and you go to right here where it says Set Measurements in the one of the pull-down menus. And you want to make sure in these boxes that you check the area, the mean, gray value, and the integrated density. So what the area does is essentially it is just like the area of what you highlighted in pixels. And then your mean gray value is obviously the mean of like the color value of the pixels you highlighted. And then integrated density is the product of those two, so multiply both the area and the mean gray value. So make sure you have both of those checked. Yeah, I mean whatever else is checked you can have, but it's not necessary. Alright, so now you have set all those measurements, I assume. So now what you're gonna do to analyze is, so they have this big bar up here, this thing that I'm sticking around. Alright, you want to find the image of like a weird little bean looking shape, and it says freehand selection, and you want to press on that. Alright, and I have a worm right here that I'm, have my mouse on. And what you want, my elegan on, and what you want to do is you just want to simply trace it. So you see like a little yellow line going around. Alright, it's fine if you get a little bit of the background in it, but try and get the best, like, all the worm in it. Okay, and once you finish tracing it, go to Analyze again and press Measure, or Command M if you want to do it that way. Okay, and then this data bar right here will pop up. And it will have, your area, your mean, and your raw integrated density, and all the values you need. So I would recommend per photo, if you're using wild worms like I am, trying to get measurements of around 3 worms per image to get the best possible data. And obviously if you're using mutant worms where you can only get like pictures of 1 or 2 at a time, then obviously just measure those. And then, so once you, trace your thing, make sure you trace around, I'd say 3 background examples. So like just little circles around the worm where there's like no other worms, and it's just like complete background, and then measure those 2. So obviously go to measure. It's pretty easy, so you just do this for everything. Just a command to M, and make sure you keep your data set kind of organized, because you don't want to forget, oh, is this the worm or is this the background? So just make sure you keep that like under control. And so yeah, I'll show you how to do the Google Sheet. Give me a second. So now I'm going to show you how to do the spreadsheet. So I would recommend doing this in Excel, but I had to do it in Google Sheets since my computer does not run Excel. So anyway, so this is how you want to set it up essentially. So you want to put your trial ideally in the top corner. Put whatever, control or like concentration or whatever helps you figure out what the data is from. And you want to put organism number at the top right here, area, mean, and integrated density. And obviously these are the 3 values you calculated using the ImageJ. And then you want, over here you have the corrected total cell fluorescence, which is essentially your data. So what this essentially is using the area, the mean, and integrated density to calculate what the actual fluorescence of the cell was. So obviously if you have higher CT-CF values, that means that your cell is fluorescing, pretty good amount, and then if you have lower values, that means that the cells are unhealthy and aren't fluorescing as well. So you have the C elegans, so you can just put C elegan 1, 2, or 3 like I did, or whatever, you know, doesn't matter. And you also have backgrounds, so I just denote them as BK just to make it easier. And what you want to do is, for the backgrounds, you just want to average the mean, so just this whole entire, you know, section. And then for the area for each worm, so to calculate the CTAF, it's essentially the integrated density, so this column right here, subtracted by the, you know, product or multiplication of the area of the worm, so this one right here, so I'll show you, or sorry, yeah, so the area right here, and then the multiplied by the average mean of the background. So essentially what this calculation is doing, it's finding like the integrated density of your actual worm, and then it's like subtracting, you know, the fluorescence of the background too, so you get the actual fluorescence of the worm. Alright, and then you just set this same, you know, this whole entire section up for every single worm. And yes, this is tedious work, and this is why most people, as you know, don't enjoy working with these worms. And yeah, so once you get all these data points, you can graph it, and I'll show you how to graph it. So now I'm gonna take you to the process of actually graphing your data. So what you want to do is you just want to set it up like a table like this, so, you know, like this whole part. So I just put conditions right here, you can put whatever you want. I just put controls. So the chemical I used was a pesticide called glyphosate, so I had different concentrations, so I just set it up that way. And then I had the CTAF. So what I did is, so if you scroll all the way up, I just averaged every single one. So I averaged this, like I made this all one big average. So it was the average of this, all the controls. So you just put you just keep on going through. You're like, oh yeah, this, enter, this, enter, you know, until you get the average, and you just put it in here. So you just put right here, put all the averages in here. Then I did the standard deviation, do the same thing. So Excel and Google Sheets have the standard deviation function, and you do the same thing as the average. So you just go through every single, you know, CTAF value, and then it'll calculate the standard deviation. So yeah, so it's pretty big, and yeah, you don't need the integrated density, doesn't matter. Anyway, so yeah, so once you have that, you can just simply, you know, highlight the whole thing and just, you know, insert graph or chart, and then yeah, it'll graph it for you. And then to get, like, again, if you're using Excel, you probably get help from someone else, but I use Google Sheets. And so yeah, so that's graphing your data, and then, you know, these are standard deviation bars you want to have. And so you can just go to customize, you can just press on whatever thing, and then you can have arrow bars, which are what the thing is. You just enter the value of your standard deviation. And anyway, yeah, so well, if you want help with graphing, I'd recommend just going to any other worm people or just anyone in this class, since they'll all help you. And just one disclaimer that I forgot to bring up is, for the integrated density, use the raw integrated density. So if I go back to the data sheet, yeah, so it's data sheets. So it has the integrated density and raw integrated density. So what you want to use is the raw integrated density, since obviously this is a really small number. So now you have the means of which to analyze all of your data for your trials, and yep, the long process. And I assume along the way people will probably come up with better ways, and you can probably consult them. But as of right now, this is the way I did it, and that's the way to get the best data. And so in just a brief moment, I'll take you to the process of making your images look, you know, a little bit more easy to see and cooler for judges if you want to put them on your poster or whatnot. Alright, so now I'm going to take you to the process of making images look cool. So still, you know, you have your image that you took from the photos, that's, you know, stack images. Alright, so you want to drive that back into ImageJ like you did before to analyze the photos. And then what you want to do is you want to go to the image tab. Sorry, you want to go into, yeah, so you want to go into ImageJ, go to the image tab, go up, look up tables, and then there's this huge list. Alright, and then you just find any color you think is cool. So, you know, like magenta hot, I don't like that one very much, but anyway, you can just keep on going through, like Les Blu-ray. Obviously that's not really good. Anyway, so yeah, so just go through every single, or don't have to go through every single one of them, but just find one that, you know, appeals to you or you think would look best, you know, for displaying your images. And yeah, so that's about it for this video. I'll put the link to like the original procedure if you want to like review that for like, you know, more in-depth analysis. And yeah, so I wish you good luck in putting all your data, and good luck at the science fair. See you.